in this part, I want to introduce inverse functions. We will be talking more about inverse functions a little bit later down the road, but I wanted to introduce them since they are very important, and let's talk about why. So an inverse function is the process of undoing or going backwards. So I like a very simple example here. Tying your shoes, right, would be a function doing the process. Undoing that process would be going backwards, right? Doing the inverse would be untying the shoe. It's one of the more simpler. The same thing with, like wrapping a present or anything. Unwrapping the present, as long as you keep it nice and neat, right? So here's an example of a function and then its inverse. Notice that the function is f and the inverse is indicated because it has an exponent of -1 that indicates that it's the inverse. The other thing that I want you to notice is that the domain of that function f, okay, which is our apples, is going into this function. The function's doing something, it's a machine, and then it's spitting out the output, which is lemons in this case, which would be your range. Okay, you can think of this as input as well. This is output. Okay, but notice what ends up happening is when you do the inverse, you're taking in what comes out of the function. So the range of your function suddenly turns into the domain of your inverse function. And then the range of your inverse function is your original domain input, okay? So essentially what's happening here with your function and your inverse is they're flip-flopping the domain and range. That's essentially what's happening. So your function just undoes everything and goes back to the original. That's what's happening here, right? Function f does something, gives you lemons. Your inverse function undoes that and gives you back the original apples. Now, I'm going to show you later on how to create inverse functions, but in this lesson, I just want you to recognize what an inverse is and that relationship between domain and output and how they just essentially flip-flop. So let's have f of x equal the function 5x plus 2. And we want to go ahead and find the values of the range. The range is your output, or y values, or your values of f of x. And your domain is your x values, right? So the domain here is our x values, -3, -1, 0, and 2. Our output, or our range, is going to be what those values are at for the function f of x. So we're just going to plug these in. That's all it's asking us to do. X is -3, so let's replace all of our x's with -3. 5 times -3 is -15. -15 plus 2 is -13. Okay, let's plug in -1. 5 times -1 is -5. -5 plus 2 is -3. Plug in 0. That one's the easiest. It just gives you 2. I love plugging in 0. Okay. 2. 5 times 2 is 10. 10 plus 2 is 12. Boom, we've got our output. We're good to go on that fact. But now let's talk about the domain and range of the inverse. So now we want to switch our domain and range from our original function to give us that inverse function, f to the -1 of x. So now we're just going to simply switch to make sure that we're inputting now the range. Essentially, you're just flip-flopping. So we're just going to put the range of your original function into your input, -13, -3, 2, and 12. And now that output of your inverse is just that original domain. That's all you're doing here. You don't even have to do any calculations or even think about it. All you're doing is flip-flopping the domain and range. That's what the inverse does, right? It says my input now becomes the output and vice versa. So inverse functions undo each other. Okay, original and inverse functions. And we'll talk about that more, but it's just getting those wheels turning around the idea of inverse.